So the derivative of the logarithm of x to some arbitrary base a is 1 divided by x ln a. And this is a standard derivative. You can look it up in any table, but I'm going to attempt to show why this is the case. So I'm going to attempt a quick proof of this. So let's start with the rule for base changes. So we can take log x and change the base. So we're changing the base in this case to e. So we have log to the base e, which is the natural logarithm. Okay, so if you know this, if we accept this, then the proof is rather easy. If you're not sure why that's the case, we can prove it. So let's do a quick proof of why we are allowed to change the base in that way. So if you look at log x, and if we were to call y log x, we can rewrite x as a to the power y. That's just the definition of log. So x is a to the power y, and then we can take the natural logarithm of both sides. So ln x as ln a to the power y, and using the property of logarithms, we can bring that y, make it a coefficient. So we multiply ln a multiplied by y. So these two are equivalent. So now we can rearrange this expression to find y. Remember, y is just log x. It's what we're looking for. So I can simply divide both sides by ln a, and I end up with this expression here. So that's the proof of our change base rule. So that's how we can rewrite this as a ratio of two natural logarithms. So now the question becomes, how do you differentiate not that, but that? And that's a little bit easier because the denominator in this case is a constant. Ln a is just a constant, so we don't need to differentiate that. And the derivative of ln x is well known. So the derivative of the natural logarithm is just 1 over x. And again, if that was unclear, or if you needed that to be proved, we can prove that too. So we'll do a quick proof to show why is the derivative of the natural logarithm 1 over x. So again, a quick proof. So again, if we were to rewrite ln x as y, then you can find x by applying the definition of log. So it's e, which is your base, to the power y. So these two expressions are equivalent. Now, if you differentiate x with respect to y, so dx by dy, the exponential is unchanged, and e to the y is simply x. And then, if you were to invert both sides, or take the reciprocal of both sides, so if we know dx by dy, we can find dy by dx by inverting it, by flipping it. So 1 over x is dy by dx. So that's how we can show that the derivative of a natural logarithm is 1 over x. So we've proved that. Now if we go back to our question, we were trying to differentiate that. We replaced that with a ratio of two natural logarithms. Now we know this is a constant, so we don't need to worry about it. And we know that the derivative of natural log is 1 over x. So we know this is simply 1 over x. So we can simply replace this with 1 over x, and this, because it's a constant, we don't need to differentiate it. I just took that outside. And now that's our final answer. It's simply 1 over ln a multiplied by 1 over x, which is 1 over x ln a. So that is our final answer. That now is how we prove that the derivative of a logarithm to an arbitrary base is simply 1 over x times the natural logarithm of that arbitrary base. So that is our final answer.